Okay. So let's make a deal that all of us will be on time on Wednesday. That's when the final starts. um, so the way the final is going to work is you will have a class period on Wednesday to do what you can with it. Then I will gather it up, give feedback, and then during the regularly scheduled university final exam scheduled time, Thursday, December 6th at 12:30, so 2 hours, 12:30 to 2:30, is when the exam will be given back to you with my feedback, and you'll finish it up. I will be traveling during finals week. I actually get back later that day, so I've asked Brianna to do the honors of proctoring this, so don't give her any trouble. Okay, now, all right. Now, I want to talk about, since I've just been grading homework for, and yes, I have received a couple more corrections. I know that there's, and apparently with everybody we're going round and round until there's hundreds everywhere.
So resubmit.
Yeah. And there seems to be, again, this does not apply to any one person, applies to several of you. Going round and round and round. In particular, on one problem in particular, I believe it was problem number 5. Okay. Where you have, sorry, I did something funny to my back this morning, so
I'm sorry.
extremely annoying. Apparently, like Peter Griffin from Family Guy, I literally forgot how to sit down. So after class, I'm so going home.
I'll be sure to email you.
Okay. Well, you won't be the only one. Because I normally have some meetings after this, and so most students would have to also. Okay. So the problem is we have phi for x between 0 and 1, 0 otherwise. And yes, I was interesting how you used the wavelet notation in your solution. And I thought, why are you doing that? This is the next chapter. Like, oh, it makes sense though. That is the hard scaling function. Now, and then to show that the convolution is 1 minus 1 for x 0 to 2 and 0 otherwise. And there will be a problem of this nature on the final, so I can tell you that right now. So it's good to talk about anyway. Now, and what happens is, all right, so you show that. And if you look at the definition of convolution, okay, and of course you want to figure out where are the pieces of the integrand non-zero, so you can see where you get a non-zero result for a whole thing. And of course, this one is non-zero on the interval 0 to 1, and you all found that you get this is non-zero between x minus 1 and x. And no, it's really no need to quibble about whether it's open or closed on the end, but I'm trying to be precise. So since phi is equal to 1 on these intervals where it's non-zero, naturally you're interested in the intersection of these two, and that intersection is going to vary with x. So you have a situation where you have this fixed interval 0 to 1, and then somewhere Could be here. It could be overlapping. It could be overlapping in either sense. Or it could be way out here. Of course, if it's over there or over here, the overall result's going to be 0. So it's these other cases that are of interest. And I swear, if I see one more of you, again, many of you did, write that the limit of integration is the absolute value of x minus 1, I'm just flunking you. So it does not happen.
Yeah.
I can assure you of that. It really is necessary to examine these cases. And because what happens is your integrand is going to be 1.
Yeah.
So it all boils down to what are the limits. Now, there may be some change of variable that leads to the unified choice of limits in those cases, but what happens is, depending on which one of these scenarios applies, the limits of integration are different. And also, which limits depend on x is different. So, so that's something that that I need to see in the work. And for some of you, I managed to after a few iterations, and I guess more iterations will be forthcoming. Okay. And think, because it's a sort of situation where once you see what happens in the individual cases, then it's something that if you want to come up with a unified expression for those cases, then it boils down to this. But to actually, but it's something that really can't really come into play until the end. Okay, so, alrighty, so that's problem 1. Will be something along those lines. So, because really what I did was I sent you an email that had look at these 6 problems. So my starting point were those 6 problems. I literally typed them in and made changes. So no, there are no carbon copies, but still, if you are able to do those problems, you'll be in good shape.
So there's 6 problems?
Yes, there are 6 problems. There is a formula sheet. I need to post that. I will soon, but I can tell you for sure what will be on it. There's not much. The continuous Fourier transform. This is from chapter 2. Chapter 2. So the Fourier transform and its inverse, just so you have that definition in front of you. Definition of convolution, right here. The Z transform, that definition is given. And also the formulas for how you get the coefficients in Haar wavelet decomposition and reconstruction. So in decomposition, you have your A's at the finest scale. So how do you get A's and B's at the coarser scales for decomposition? And then for reconstruction, how do you go the other way to get A's at the finer scales until you're done? But what we'll do is I'll make up a problem of that kind, and we'll just step through it. Okay. Okay. Problem 2 on the test is like this. Problem 1 is just I give you a function, compute its Fourier transform. So use whatever properties or definition, and let's grind it out. Although I do want it to be simplified as much as possible. Okay. One of the homework problems that was on the list was is proving a theorem or parts of a theorem about properties of a Fourier transform or its inverse. So I just um, looked for a different property, well, one that's not on it in that theorem, and so prove that it is true. Um, Again, like using a definition and such. Okay. Another homework problem. You're given a sequence. Find the z transform of a sequence. So that's one of the problems. And again, the goal is to not just apply the definition, but try to condense it as much as you can. Because if you can recognize that z transform is a certain simple function, then it's something that is helpful. Okay. And then the last two problems are wavelets. So one problem is decomposition, one is reconstruction. So you're given the given a piece. So like for homework problems, you're given a piecewise function defined on 0 to 1. Come up with the decomposition into W0, W1, etc. If you're given that decomposition, like the A0, B0, B1, B2, those coefficients are fine scale coefficients, kind of like what you started with in the previous. I'll let you know right now the coefficients will be different between problem 5 and problem 6. So I thought about just making them inverses of each other, but I was like, nah. Yeah. So don't you see that? Oh, we got different coefficients. Like doesn't mean they're wrong. In fact, it means you have a chance that they're right. Okay. So all right. So I do want to talk about wavelet problems. I'll do. But first, does anyone have any problems that you have questions about? I've received a few submissions, for homework 5. So how's otherwise coming along pretty good. For those of you who not.
In 15 last part, I can't see what is in there.
Oh, like in the book?
Yeah.
Oh. It is the worst PDF ever. Okay. So that's chapter 3. Okay, and the last part. Okay. I assume what you're referring to is this. It asks you to prove. Okay. N inverse, so 1 over n, Fn transpose A, Fn conjugate equals D, where it's and the reason for the n inverse is that so really what we have here is Fn inverse is equal to these two matrices on either side of the A are inverses of one another. This is what's called a similarity transformation. Something that will be a topic of importance next semester. Okay. Our matrix diagonal asymptote of P inverse AP is a diagonal matrix. So these would be eigenvalues. So that was the thing you were wondering about? Okay, yeah, because that 11 minuses or pluses cannot be seen. So I could see how that would be a problem. Okay. Any other? Okay. Um, any questions about anything? Okay.
How many people have done homework 6?
One.
One.
Or one has turned it in.
So now the question is, was it a wise decision to do homework 6 and put off the revisions? What do you think? Oh,
No.
okay. And for this Wednesday, it's just going to be the usual.
Yeah.
Last time.
Yeah. Okay. All right, now we'll go to the land of wavelets. Okay. So I'll just make something up here. It's make it easy to check my own work. In this case, I will make the problems inverse of each other. So you can see the decomposition and reconstruction process. Okay. So we'll have x f defined on 0, 1. So define it in 4 pieces of width of 4. Okay. Okay. You guys get to help me out here. Give me a number. Not a huge ass number. A number of modest size. It can be positive or negative. It could even be 0.
Okay. My personal favorite.
5.
What?
5.
Okay.
-2.
What?
-2.
Okay. What's your personal favorite?
My personal favorite, 1, 0, -1.
Oh, okay. Oh, like equally. Okay. All right. All right, one more.
Three.
Three.
I said it first.
Okay, you. Well, we're done.
We need otherwise. We need otherwise.
That would be zero. One of your other favorites, zero.
Zero, yes.
Next time.
Next time.
So sometimes he use it for the test.
No, the test is already written.
Okay. So what it means is for coefficients, I'll try it as a vector. So this function is in V2. So because we have, so normally it's in B capital J with 2 to the capital J points or subintervals. Now, in the case where this is 0 to 1, which we've been doing in all our examples, so they won't throw you off that much. Otherwise, there'd be some adjustment for that. So we have 4 points, so 2 to the 2. So it's in B2. So I can take these and list our coefficients for A2. So that would be the numbers here. Okay. So in other words, to sum over K, A, K2, 2 squared X minus K. So these are the Haar scaling functions compressed to be equal to 1 on intervals of width 1/4. Okay. So what's going to happen is A2, our process before I carry out. So A2 is going to split off into B1 and A1. Then B1 is part of our decomposition, so we'll keep that. A1 will be split off into B0 and A0. And in this case, the decomposition is complete. So we're going to have A0, which is just multiple Haar scaling function. And then B's from 0 up to capital J minus 1. All right. So as far as the formulas are concerned, we have this, that J minus 1 is equal to 1/2 AJ 2K plus AJ 2K plus 1. So we're going to take neighboring coefficients and just average them. And then B, KJ minus 1 is 1/2. We just subtract them. Okay. Now, what I'm going to do also to make sure that everything is correct, because as I showed in a class previously, I have MATLAB code for this. So if I put in my coefficients, 5 minus 2, 1, and 3, gotta make it a column vector. Okay. All right, so now I see what the coefficients are supposed to be, and let's see if it actually happens. Okay. So what we have is for first B1. So we have 4 coefficients to start with, so we're only going to have 2 coefficients in B1. So that comes from subtracting neighboring coefficients. So what should they be? So let's work with these pairs. Just using this. Okay. So 7/2, and then we have 1 minus 3 is minus 2, or 2 is minus 1, and that matches my code, so good. All right, so we have B1, and then A1. I'll make sure I'm getting all this. Okay, so what will that turn out to be?
Three over two and two.
Okay. All right. So anyone see how we got these? All right. Okay, B1 we keep. A1 needs to be decomposed into B0 and A0. So working with these neighboring coefficients. Well, these are just going to be a single number in each one. Starting from working only with these. We're done with this now. I'm going to have to pull up my cheat sheet here. Starting with B0.
Three over two minus two is 1/2 times 1/2 is 1/3.
Okay, so what do you? Okay. All right. So what do we end up with? Yes. Yeah. So 3 over 2 minus 4 over 2 is minus 1/2, and we divide by 2. Okay, and then A0. What? No. Yes, it's positive.
Adding.
Yeah. Yeah. Okay. All right. Yeah, so all that comes from using these repeatedly until we have the whole decomposition. So your answer would consist of A0, B0, and B1. So just A0 but for the A's, and then all the B's. But you still need these A's as an intermediate step. So I'll circle. This is what I'm really going to look at here. So if I give you, say, 16 coefficients at the start, 16 pieces, that would be in V4. So your answer would consist of A0, B0, B1, B2, and B3.
So for the A's, you're never going to have more than A0.
Right, you'll still compute the other A's, but yeah, so your answer, yeah, just A0. With that and all the B's is enough to reconstruct. Okay. So one thing to keep in mind is the value of A0 is always going to be the average of your original coefficients. Because you add all of those up, you get 7 and then over 4. So for a hard way, it always works out that way. And And then, yeah, definer scales, whatever you have here, the averages over the appropriate subdomains. All right, so any questions about this before we look at reconstruction?
I just saw some sound. What's the level? Is this level 2?
Yeah, so really, you're going to have the number of coefficients given to you is a power of 2. Whatever power that is indicates which v you started. And you're going to have v's all the way up to that level minus 1. So I have one written up for tests, so it's like, what's the number of coefficients that produces some challenge but is still humane? Which you also worry about, well, probably fills a page.
So we're talking Vj where j is greater than 2.
That is a certainty, yes. What's still an open question is how much greater?
How much greater? Well, I'm going to go out there on a limb and assume it's not V10.
Yeah, but that's safe.
Okay, so we've got a limit here.
Yeah.
V9 isn't a whole lot better than V10, and V3 isn't a whole lot worse than V2,
Yeah.
so we've got a constricted limit here.
Yeah. Just imagine the LaTeX nightmare of doing V10. Let's think 1,000 coefficients.
Yeah,
1,024. Yeah, that's for MATLAB.
Oh yeah.
Okay. All right. Now, okay. So as far as how we would unwind this process, okay. I don't want to leave this stuff on the board. Okay. So for reconstruction, you have A's and B's, and you're trying to get A's at the next finer level. So what happens in that case is A, L, J is equal to, so we have so all the coefficients that you're getting, depending on whether the index is even or odd, and we're not dividing by 2 at any point, that determines which of these formulas you use. So now here, in our case, we have A00, so I'll put in the subscript here, is 7/4, A, and then we have B00 is -1/4. So then by that, A10 would be equal to just the sum of these. So we have 7/4 -1/4 is 6/4, so it would be 3/2. All right. Okay, so and then we have other coefficient, the second coefficient in A1, which I have written here as a vector. So that would be 7 fourths minus 4, 2, which thankfully matches the A1 that we have over there. So this is a correct inversion of the decomposition. Actually, I'm going to label this for your notes. Okay. Now we have A1. B1 is part of the decomposition. And now we have 7 halves and minus 1. So now what we can do is, so these first coefficients with subscript 0, those will be used to get coefficients 0 and 1 of A2. So A02 is equal to A01 plus B01. So these two coefficients. So we get 5. And then we have A12 will be equal to A01 minus B01. So we're still working in the same pair of coefficients. So that's going to be 3 halves minus 7 halves is minus 2. And then we have a 2, 2. So once we move up to the next pair, so coefficients numbered 2 and 3, we work with coefficients numbered 1 from the previous scale. So notice L is equal to 2k or 2k plus 1. So that would be a 1, 1 plus b 1, 1. So that's going to be 1. And then finally we have a 3, 2 is equal to a, alright, so that's going to be 1, 1 minus. So it always goes this way of adding from that pair and then subtracting to get these coefficients in sequence. So 2 minus 1 minus 1 is 3. Okay. So any questions about this? Easy peasy lemon squeezy? As one of your fellow graduate students often says. I won't say who, but probably not. Well, yes, the thing to ask yourself is, can you reproduce this on a test?
I'm gonna do a whole lot more than ask myself if I can reproduce on a test. I'm gonna see if I can reproduce it at V4 in 10 minutes.
Okay.
You know, I mean, that's the real game here, you know?
Yeah, well, and also, without making careless mistakes.
Well, let's be modest with, with our goals here. I mean, one is trying to do a 3-hour test in an hour and a half, but you actually get those 2 extra hours. So I'll be armed with an eraser.
Like if you have V4, you have 4 to the power j points.
Okay, no, wait. No, it's always 2 to something.
Okay.
So V4 would be 2 to the 4
Okay.
points.
Okay.
That seems like a page worth of notes.
Yeah. All right. Okay.
Well, I certainly hope that that's the quantity.
Yeah. Well, okay. I cannot imagine doing 5.
So you are starting with a to the power 4, a4 like
It-
a4 a3
Uh,
a2 a0 like that.
Right. Yeah. Yeah. Maybe for decomposition, you'd be given A4,
Yeah.
and you decompose it into A3 and B3,
Okay. Okay. Yeah.
and then from there. Okay. Any other questions?
Because at least I didn't go to chapter 6 yet.
What?
I didn't go to that chapter yet.
Oh, okay. Right. Yep.
It's completely new.
Okay.
Well, considering 2 of the test questions are you know, from homework 6, it's worth doing.
Oh, we have 2 days.
Well, chapter 4, 1, and 7. I mean, that's the first and last problem of
Yeah.
homework 6 set.
We have 2 days to go through that.
And
I don't think so.
a couple of the problems happen to look similar, so yeah. So. Dr. Lambert, should we expect that homework 5 and homework 6 should be graded in enough time to do reviews or revisions, or should we just
Well, I will.
assumption that it would be-
Okay. I certainly will be able to grade whatever I have, during this week, because it doesn't really take that long to do them, and which makes it all more sad if it took so long to do homework 3. So, yeah. So, okay. Yeah. Because well, certainly you will be able to use whatever went wrong on homework 5. Well, anyone who chooses to turn in homework 6, to take it into account for when you get the final back on next Thursday, to try to fix things up. So since the lowest homework grade is dropped, so I imagine that means the majority of you will choose homework 6 to be the drop grade. However, what you are welcome to do is work those 2 problems of homework 6 that I told you will be featured on the final, and just turn those in. Now you might not even need to do that, because those problems, they might have the answers in the back. I didn't.
I'll be honest, I didn't check.
Yeah, I haven't checked. So yeah.
Yeah, honestly, they chose a wonderful way to put those answers in the back. They wrote them in such a way that you have to be a flaming genius to extract anything from them. So.
Yeah.
I didn't know
Okay,
that.
Well,
I find the comments on the homework more, far more responsive.
Okay, well, that's good. Well, out of more curiosity, let's see if they are in the back. Problems 1 and 7 in chapter 4. They are in the back. So you have that to check against. Although I will say that the format of the answer for problem 1 leaves something to be desired, but it's still workable. Okay, so all right, so you can practice on those. Those are benign cases like these. Not many coefficients. Well, actually, number 7 has 8 coefficients, so that's a little more involved than what I did here. So that'll represent a good practice opportunity for you. Yeah, so then you'll be ready to rock. Okay, but with drip, bless you, drip of assignments coming in. What I tend to do when it's a first time grading a particular assignment, as opposed to revisions, I try to wait till the submissions reach a critical mass, so then I can just blast through them all at once. So I've received homework 5 from only 2 of you. Okay, so there needs to be something more happening there. Okay. Oh. I'm sorry, you'd asked me a question about number 14?
Yeah.
Okay.
I only had the problem with 15 last part.
Okay, but for some reason I saw that email and I didn't really read it. I thought, oh, that's just submitting the assignment. So I filed it in my folder of stuff to grade. Instead of, I didn't realize there was a question about the assignment. So, whoops. Plus, it was Sunday and I was goofing off anyway. Okay. So, number 14, part C, or were you able to get that figured out later? Or I can still talk about it.
Yeah, you can talk about it.
Okay. Let's see. So that's chapter 3 from 14. Okay, and it was okay, wait. All right. Part C. Oh, what kind of an answer am I looking for? Okay. So finding eigenvalues and eigenvectors. How are these related to the matrix columns for a matrix? That's a really weird thing to say. What other kinds of columns would they be? So columns of F4.
We can always talk about lattice columns.
Oh, yeah. Okay, so what I'm looking for first, just listing the eigenvalues and eigenvectors, so I can also see which eigenvalue corresponds to which eigenvector. And so then, if you were to take the eigenvectors and write out the matrix F4. Because that's a big question. How are these related? Like for instance, do you have equality? Are they scalar multiples of the eigenvectors? Or because eigenvectors are not unique; they're directions. What can you say about the directions of the eigenvectors versus the directions of the columns of F4? And so the thing is, if the columns of F4 are parallel to the eigenvectors, then the answer is yes, you can diagonalize the matrix using an FFT. So really what I'm having is after you compute them, just go ahead and check that.
Diagonalize matrix using an FFT? It's so revolutionary. I hope the biting sarcasm was.
Yeah, I could detect it.
Well, at some points I did the kind of, there are things equally stupid. I mean, I will be submitting a resubmit, so none of this one.
Yeah.
Well, getting that back at some point, and maybe submitting a resubmit.
Yeah. Okay.
If the other ones are anything to go by, I'm going to go out there on a limb. Assumptions there, but
Yep.
hopefully not that problem.
Okay. Are there any other questions? It's a video of today's class, the formula sheet from the test. So, and yeah, I listed down, but you can have it in front of you.
And the formula sheet will tell us what to memorize. Anything we don't want to, anything we wanted there that doesn't appear.
Yeah. Memorize.
Not to memorize. Yeah.
Okay. Yes. But complement of that with respect to some universal sets.
Yeah.
And
the intersection of things we want to know.
Yeah. Sounds like a scary Venn diagram exercise.
Yeah. See, we're already putting real analysis to work in a practical way.
You know what's funny is the only time as a student I ever had to deal with Venn diagrams was in 7th grade. And for some reason, I just could not do them. I was awful. I got a D on that part. And
I blame the teacher.
it was my Achilles heel. So it's the only time I ever got a D in anything in math. Well, oh wait, no, it's not. I did get a 25% on the test once, so yeah. But that's what happens when you take a graduate level complex analysis class as a sophomore.
Well, but everybody has to have one of those classes that just informs us about the nature of the world.
Yeah, and one's limitations. Yeah. All right. Well, but yeah, that's all I have. So of course, I'll stick around if anyone has any questions. I'm going to go home and do something about my back. Dang it. Okay.